Hello everyone. In this video, we'll see how we can identify and remove the duplicates in a SAS table. Note that your SAS table is provided to you already and that is available in the libraries, maybe under a user-defined library or by running a libname statement, or it may be under the work library. Now there are two things that we can do it here. So when you identify a duplicate, you should identify it in a proper way. You may be finding out a duplicate which is exact replica of one row. The same row may be repeated twice. So you want to remove the entire one of those lines and retain only one. That is one thing. Second, you for a given entry you have multiple entries in a particular table. That is, for example, for a given student there may be multiple entries. Out of that, the entries may be different, each row may be slightly different, but of that only the first value you would like to retain. So that is another way of doing. So there are two things that we can do it. So we use something called as no DUPRECS, DUPRECS and uh, another one is no DUPSKEY. So two different types will be making use of. So first let us go through what it is. So this is used within a proc sort statement. So the proc sort statement itself will be using, and within the statement, proc sort statement itself, the first statement itself, will be using it in under options. So the options are within the statement. So the proc sort statement goes like this. Proc sort will be giving the input of the table as we have discussed in the previous video. Then again you will give the output table. It's exactly same as we have done earlier. Now in the previous table we have not previous video we have not mentioned anything further options. So this is an extra thing that we are going to do within the semicolon. Once you start proc sort, within the semicolon, within that we are writing the entire thing. So you'll write data input, you'll write data output, the SAS table output you'll write. After that you'll write the keyword no DUPRECS. So this particular keyword represents there is no duplicate row. Once it is sorted, so the duplicate row, if it is existing, that will be removed. Now if you want to remove it, and those removed rows you still don't want to remove it altogether, because sometimes because of some errors within your SAS table, uh, required rows, if it is deleted, you will be in trouble. So you may want to just verify it once again. For that reason you require that information as a side table, that is additional table, that you can take it out as a dup out is equal to table, output table. So in this particular statement you will get two output, one without the replica, that is out is equal to what you write here, that is the actual table that you wanted. Then you come across something, one more table, that is dup out. This particular SAS table, dup out SAS table, is the duplicate. There may be a one value, there may be multiple values of the same row. Possible that one single row is replicated some 10 times. So if say that you have one single row with your USN, with your name itself, with the particular value, set of values, it is repeated 10 times. The first instance value, it may be considered here. The remaining 9 will go to the dup out. Now this is but since it is involving all the rows, you will have to write by all. So this is the keyword that you need to write, that is the sort by all variables. So underscore all underscore. So this represent all the variables which are present there in that particular SAS table are considered for sorting. So that gives you an advantage that exactly look-alike rows will be next to each other. It is easy to remove them, right? So that's for the exact look-alike rows you will be using no DUPRECS. That's the keyword that we're using, and by all. These two are linked to each other. If you want an output, it is dup out. Now let me go ahead with the one more type. So that is no DUPSKEY. So no DUPSKEY, what it does is it's exactly similar to no DUPRECS. Input table you have, output table you have. Instead of DUPRECS, we'll be using no DUPSKEY, no duplicate key. So that means you will be using a keyword. One keyword you'll be using, and that keyword is defined by the column. The set of columns what you'll be using. So based on those columns, the first instance we'll be considering, and the dup out again you can save it as the one table. You can use by descending or ascending, you'll be using. Remember, by, that is all, underscore all, you will not be using for no dupe key option. You'll be using a particular set of columns. Let's look at some examples here. Here we use out data input table as class test3 under pg1 library, and output is test clean. So usually this is the conventional way of writing. Out is equal to the file name, one particular file name, underscore clean. That means it indicates that duplicate values are removed. Okay, so this is one user defined way of writing some file name so that we understand it easily. And similarly, after you write duprex, no duprex, the dupe out, what you write, the output file of duplicated values, you write instead of clean, here it is dups. So dups indicates that all the duplicate values are here, all the clean values are here. So the original test3, class test3, this file has got say if there are 100 rows, if there are unique 55 rows, it will be present in this one test clean. Remaining 45 rows are which are duplicate of some rows here, that will end up with test dupes. And see that we have written by all. Okay, this is just an example. Say that Barbara math 96, Barbara math 96, these two are exact duplicates, right? So these two, when you sort it, this is the original table. When you make a sorting, they come next to each other, these two come next to each other. Of this, the first instance will be in the test clean. Here it will be in the test clean. The second instance what appears will go to the test dupes next table. So all the unique rows will be remaining there. Look at this, Barbara math and Barbara reading, these two are different rows, the rows are different, so this will be retained as it is. Now let us look at the no dupes key example. Now the same example, class test2, test clean and test dupes will give no dupe key. See that no dupe key I have written here, earlier it was no duplex, it was written up. So in any order you write, it doesn't matter. Within the statement, any way you write it, the options, the reverse order, that is no dupe key up or down, it doesn't matter, but it should be within the um, that semicolon. So it is sorted according to the name. So by name it is sorted. So when you sort it by name, the entire thing, class test2, what will happen is the test clean will have Barbara math, and test dupes will have Barbara reading. So there are two names, Barbara math and reading. Of this, Barbara math will appear here, Barbara reading will appear on the other side. That is, out of the two Barbara, one Barbara is taken here, the second instance of Barbara is taken on the other side. Why it has taken this way? It is because we have sorted according to the name. Okay, so we'll look at the SAS Studio for sample problems. So we'll look at the examples 3 and 4. Let's go on to the SAS Studio now. Here we are in the SAS Studio. So I am in 6A03. Now this is the syntax which we have just seen. The two syntaxes, that is one for the no duprex, remove the whole row. Another is for no dupe key, remove the first instance of a given keyword. Alright, so there are some questions. Let's look at that and let's go ahead. There are three questions, am I right? Yeah, we have three questions. Let's solve one by one. Modify the first proc sort step to sort by all columns and remove any duplicate rows. Means whole row should be removed. So I'm supposed to use no duprex. Write the remove rows to a table named as storm underscore dupes. So the output should be tom underscore dupes, which one? The removed ones, duplicate rows. Highlight the step and run the selected code. Confirm that there are 1,07,821 rows in the storm clean, 214 rows in the storm dupes. So I get storm clean one file, storm dupes another file when I sort according to this, the question number 1. So this code is already available to me here, readily available. So since it is pg1 library, I have to ensure that I have the library pg1 readily available with me. Yes, pg1 is available. So if you do not have pg1, you're supposed to run the libname statement, global statement. Once you run it, then you get the pg library, then you come to this problem. So look at the statement, proc sort data is equal to pg1.storm detail. This is the input file, right? This is the input SAS table, and the output SAS table, that is the without duplicate, it is storm clean. Then I'm using no duprex keyword, that means no duplicate rows should be considered, and if there is any duplicate, that should go and store in the storm underscore dupes. I'm sorting it by all. So this is one statement, second statement, third statement. So three statements of the proc sort step I'm selecting and executing. So I'm expected to get somewhere about 1,07,821 observations. That's what it is mentioned in the question. So let's look at that particular. Uh, okay, yeah, here it is. Confirm that there are 1,07,821 rows in the storm clean and 214 rows in the storm dupes. So let me go to the output, and I see that work.storm clean. So in storm clean file I have 1,07,821 rows as mentioned. Then when I click on this, I can find one more file here which is output dups, work.storm dups. I can select that. When I select that, that particular file, the duplicated file appears here, and that is 214 file rows are there. So let me just verify the duplicated thing. So look at the rows here, just try to compare the row 1 and row 2. Let's look at this 1981 SI, MM, LIC, Luisa. The timings are slightly different, types are different, latitude, longitude, right? So almost similar they are on a almost similar line, right? So they are, the duplicates are removed. So this is the advantage of this. So if you remove that, the file can be stored and you can do the verification. Now let's look into the second question. Run the second proc step, sort step, and confirm that the first row of each storm represents the minimum value of pressure. Why? Because the storm names can be reused in multiple years and basins. For a multiple year, the same storm name can repeat. For in a given basin, the storm name can be repeated. So the unique storms are grouped according to this. Let's look at the problem first, right? Yeah. So here it is. This is the um, code. It's already readily available. Let's see this. Data is equal to pg1 storm detail. Output will be min underscore pressure. So that will be the output file. So there is no duplicate value or considering something. Let's look at this first, where pressure is not missing. Look at this, pressure is not missing means if the pressure value is absent, dot, pressure is a numeric variable. So if it is dot not available there, that, and name is not missing, right? If name is not available, right? So is not missing is the keyword here, means if it is missing, don't consider. Only those where pressures are not missing. And this is another keyword we have here. So and name is not missing. So that means in simple, consider all those rows where pressure is some number, name is some character, some values are there for their name, right? Only those missing values, if it is there, do not consider them. That is what you can understand from this where statement. Now within that, you have to sort. This is proc sort. You have to sort by season in a descending order, then basin ascending order, name ascending, pressure ascending. When you say pressure ascending, the smallest value of pressure will come in the first row, right? That is what is meant by this, represent the minimum value of pressure, right? So let us run this particular program. Select only those proc sort and the question 2, run. The pg1 library is already existing, so I don't have to write the libname again. So let's look at the, let's make it a grid to the column. Yeah, the first row 216 EP, basin EP, right? We started with the season first. So season is 2016, and it goes on. There are several values, thousands of values. Okay, so since it is descending, the latest season will come up. Descending means highest value first. Descending value is the reverse of increasing order, right? It's descending order, latest first season. Then you get basin and name. So basin is alphabetically sorted A to Z. So the first instance comes is EP only. Then within that agatha, right? So you can see that it is repeated, the mini agatha, but and at a different I mean same season, same basin, right? Then what else we have sorted? We have sorted name and pressure. So let's look at the pressure value. Yeah, here it is 1002, 1002, 1004, right? For the same value of 2016 EP, then Agatha, for same set of values we have pressures different values, right? All these are different values. Look at the numbers 1002, 4, 1007, 8, like that you have. And I think for all of this it is Agatha EP 2016 EP Agatha. Now this is what we are supposed to observe. Okay, we have done the observation. The next question, modify the third block sort to sort the mean pressure table. All right, mean sort, the output is min underscore pressure. This table what you have created, SAS table, it's named as min underscore pressure. Now that will be the input for the question 3. That will be the input for the question 3. Use that and keep the first row for each storm. That means this storm, Agatha storm, you have to retain the first row only. This first row only you have to maintain. The remaining rows have to be removed. Right. Then you do not need to keep the removed duplicates. The removed duplicates you need not keep it as it is. Okay, that's the requirement. So first row only you have to maintain, means only for the first pressure value only we have to retain, means first let us sort accordingly as it is the way we have, and let us not consider the pressure. So only the first row of the pressure will retain, because we are using the no dupe key here. So the no dupe key indicates only these variables. If it is repeated, these three variables, if it is repeated, only the first variable will be retained, remaining all will be deleted. Season basin name, what it means is season basin name. So you have right now in this particular page you have same value up to Agatha, where it ends. Yeah, here it is. This is the last value, 2016 EP Agatha. So 29 values are there. Of this, 2 to 29 will have to be deleted. Retain only the one, that is only the minimum pressure, the first value pressure 1002 should be retained. Remaining all I want to delete it. Okay, so first the same thing I have to retain it, and pressure one value is sufficient for me. The first value, lowest value of pressure is sufficient. Possibly I'm trying to find out what is the lowest pressure in all those seasons. Okay, so let's look at it. Yeah, you see that. Let me make it a grid so that we can observe it properly. 2016 EP. Look at this name, Agatha. Right after that is Blas. So Agatha is only one, and which Agatha is retained? Let's look at the pressure. It is 1002. So 1002, the lowest pressure value is retained. All other pressures are removed. Right? So that's the key difference between no DUPRECS and no dupe key. The no DUPRECS you need to use Y all, and whole row is removed. All the rows are removed. Whereas no dupe key, based on the particular key value, if it is a key value is repeating, whatever may be the next column values of that doesn't matter. All those things will be removed, eliminated. So these two things are required at different occasions. So use it in a proper way. Now in the activity 604, simple one, I asked you to open the PG1 library and go through the NP large parks table. So that is under PG1 library, you scroll through the NP parks library. Okay, NP large parks table, double click on that, it will open up as a SAS table. Just observe that there may be some duplicate rows in some cases. You can just observe it, and visually you can see it. And now you have to write a proper statement. So I want you to have two tables, one called as park clean. So the input table data is equal to, you have to write the SAS table name, that is pg1 dot, you have pg1, right? You have pg1 dot np underscore large parks is the input file. Output file, there are two output files you have to write. One is with the clean, another with the dupes. That is park underscore clean and park underscore dupes, right? So dupes for the dupe out, clean for the out. And it's not mentioned whether it has to be permanent or temporary, so you can use work library itself, or you can simply write the file name. It goes and sits in the saves in the work library. No DUPRECS, fine, by all. I think, yeah, only three items you are supposed to enter. Right, execute this program, but before you execute, ensure that your PG1 library is active. For that you require the lib name statement to be executed. Yes. That's it for this video lecture. Thank you.